Okay, so this is the beginning of chapter 2. This is section 1, and we are simplifying square roots. With and without variables, okay? So your goal is to be able to break down the value under the radical until it is in its lowest terms. Okay, and the better your multiplication is, the easier this is going to go for you. So I'm going to show you how to do this with a factor tree, and then if you struggle with that, I'll show you also how to do it another way. All right, so let's take as an example the square root of 20. Okay, well, we're going to take that and break this into any factors of the radicand. The radicand is the number under the square root symbol. Okay, so we're going to take the 20, and when you break these down, make sure you break these down into values under square roots. So I'm going to use 4 and 5. Okay, 4 and 5. And then if a number's prime, you can't really go any farther. So I can't do 5 because that's prime. So now I'm going to do the 4 is a 2 and a 2. Okay. And then those can't go any further because they're prime. If you want to, if it helps you, you can actually cross out the numbers that are not prime. So 4 is not prime, 20 is not prime. All right. And then what we're going to do is we are going to circle pairs of roots. Why? Because a rad 2 times a rad 2 equals a rad 4, and a rad 4 is just a 2. So if you have a pair of them, you can get a single value out of there. For example, excuse the bell. This is going to be obnoxious.
Students, your bus is in the front of the building. Again, if you are Louisville, your bus is in the front of the building. Thank you.
So sorry. So a rad 5 times a rad 5 equals a rad 25. Well, the root of 25 is just plain 5. So 2 radicals give you the number without the radical. So what this does is this gives me a single 2. And if this doesn't pair up, it has to pair up to get out of the radical. Then this is just going to be a radical 5 in the answer. Okay? So again, the better you know your multiplication, the better off these are going to go. All right, so I'm going to do one here. We'll do the root of 48. Okay, and I'm going to throw this line paper over here because it's simpler. So the square root of 48. And let me show you a couple examples where it doesn't really matter how you do this. Okay, so some people might go 48. Well, that's 6 times 8. Other people might go, oops, this is supposed to be an 8. 48, well, that's 2 and 24. Other people might go, well, that's 16 and 3. Those are all true. So watch what's going to happen. Let's work on this one over here on the left-hand side. The 6 will turn into a rad 2 and a rad 3, which means I can get rid of the 6. The 8 is going to turn into a 4 and a 2. So I'm going to put the 2 first. 2, and it doesn't really matter, right? And then the 4 is going to turn into a 2 and a 2, and the 4 is going to go away. All right, so this is interesting here. These 2 pairs of 2 will give me a 2. This 2 and this 2 will give me another 2. And I would multiply those 2 things together, and then this little 3 here is left out by himself. So I have a 4 radical 3. Okay, let's jump over to the one on the right-hand side. Look what happens over here. The root of 16 is a 4 times a 4. Well, there's my pair of 4s, and then the radical 3 is by itself. So if you know that the root of 16 is 4, you can just do that, and you have the same answer there. Okay, let's take a look at this guy over here. The 2 is already prime, so I'm going to go 24 is what? 6 times 4. Okay, so this is 6 and 4. That's gone. The 4 is 2 and 2. That's gone. And the 6 is 3 and 2. So I have a pair of 2's here, a pair of 2's here. The 2 times the 2 are 4. And there's my 3 that's left over. So it doesn't matter which sets of factors you pick. You're going to get the same answer no matter what. But notice this guy over here was the shortest one because 16 is a perfect square. And if you know your perfect squares, you can break these down and make them simpler. Okay? Another way to do these is to use what's called the ladder method. This is called the tree method, by the way. You're making factor trees, right? So the tree method. So what you're going to find out about me as you go through this class is that there are multiple ways to solve math problems, and I don't really care which ones you use. Just use one that is the most effective for you and is mathematically correct, okay? So let's take this 48. I'm going to go to another new screen. So new screen, pull the paper over. We're going to do the root of 48, but I'm going to show you a different way to do this. So this is the ladder method. And if you struggle with losing track of stuff and you want to keep stuff really linear, this can be a better way to go. So what you do is you take the number you take the radicand, you put it over here, and you put it in an L, okay? Now the deal with the L is you're going to put a factor here, and you're going to put a factor over here. So one's going to go on the left and one's going to go underneath. And then the one on the top has to be a prime value. So I'm going to go 2 and 24. This one down here is not prime, so I'm going to do that again. 2 and 12, not prime. So 2 and 6, not prime. So 2 and 3. And then I'm just going to circle pairs like we did before. So those 2 will give us a 2. Those 2 will give us another 2. And then we have the 3. We multiply those together. So there's your 4 radical 3. Okay, so we're going to continue on with this video. There's 2 more pieces that you have to know about before you can successfully do any work. And that is dealing with radicals with higher indices or indexes. Okay, so when I have a radical, normally we talk a lot about square roots, and it's assumed that this little number in here, this invisible number, is a 2, hence the square root. But if you see a number that is other than that, or there is a number in there, well, that number is the index. Okay? And that number tells you how many things you have to circle to get one out. For example, when we did let's just do a square root of 12, right? If we go root of 4, root of 3, and then the root of 4 becomes a root of 2 and a root of 2, then we have these 2 become a 2, and this rad 3 comes down here. So we circle 2 of these radicals because this index is a 2. Okay? Well, now, if we have something with a higher index, that means we have to circle more numbers to get one out. We also have to put that index in our answer, all right? So if I do, let's use this one right here, the cube root of 48, all right? Well, I'm going to break that down the way I did before. So I'm going to go, and now I would go all the way to primes. Okay, square roots aren't going to matter anymore. So don't think about 16 times 3. That doesn't matter. We have to go all the way to primes. So 6 times 8, and then we're going to go 2 and 3, and then this becomes a 2 and a 4, and these can go away, and then the 4 becomes a 2 and a 2. Okay, well, my index up here of a 3 means I have to circle 3 of something, anything, to get 1 out. Okay, so if I circle 1, 2, 3 2s, that gets me 1, 2 out from under the radical. And if I have these 2 left over, they have to stay under a radical because they don't get buddied up. So they're going to get multiplied together. And I'm going to have a radical 6. And I need to make sure I have this index in my answer. So this is going to be 2 cube root of 6 when you put that in. And when you go to varsity, there is a way for you to click on that little equation editor, and you're going to see an option that's going to have like the root, and there's going to be a little box in here. So you're going to choose that, and then you'll put your little 3 in there for the index. Okay, so that goes inside the foot of the square root, just so you know how you're going to be writing that. Okay, the next thing we need to talk about is how to take square roots of variables. So I'm going to go to another page, grab some paper, and we're going to talk about taking variables from under the root. Okay, so we'll do a pretty basic one, and then I'll do a bigger one, okay? But these work the same way as so these work the same way the numbers do. And what I mean by that, oh, I hate when these little boxes start showing up. What I mean by that is that you're going to, if it's a square root, you're going to pair up 2. If it's a cube root, you're going to pair up 3. Okay, so if I had something that looked like the square root of, well, I don't know, 108. Let's do a square root of 108, x to the 5th, y to the 3rd. Okay, I'm first going to deal with, I'll kind of deal with these all separately. I'll do the root of 108. Oops, 108, sorry. And then I'll deal with the root of the x to the 5th. And then I'll deal with the root of the y to the 3rd. Okay, so we'll kind of deal with these separately. What goes into 108? I think 3 does. So I'm going to find that out the long way. So 3, this goes in here. 3, that's 18. So 36 times. So I got a root of 3 and a root of 36. The root of 36 is a root of 6 and a root of 6. So I can circle those and get a 6 out of there and have that 3 left over. And then when you're dealing with the variables, what you're going to do here is kind of list these out. And I'll do that in a different color. But x to the 5th is 5 x's, right? So you can circle 2 to get 1 x out, circle 2 more to get another x out, and this guy can't get out. So this x squared here will go out front. So I've got a 6 x squared. And underneath the radical, I'm going to have this 3 from over here and this x from over here. And we still have to deal with the y's. So we're going to take a y times a y times a y. I can group 2 up to get 1 out. That one's going to go outside. And this guy by himself has to stay inside. So I'm going to have 1 y out and 1 y in. Okay? Let's take a look at one more example, and then we'll be all done with these notes, and you can move on to your varsity assignment. So we've got a new page. There's some lines. All right, so the problem, this one's going to be a cube root, and we're going to have 1372, x to the 9th, y to the 3rd, z to the 5th. All right, so I'm going to take the number by itself, and that is 4 times 343. So I'm going to have a root of 4 and a root of 343. Well, the 343 is a 7 and a 49. And a 49 is a 7 and a 7. Okay, so the 49 can go, the 343 can go. These 3 7s are all going to get circled because of my 3 up here, right? So we're going to keep that in mind. Then I'm going to have x's, 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm putting them in groups of 3 on purpose because of that 3 as my index. So there's 1 group of 3, 2 groups of 3, 3 groups of 3, which means I'm going to have an x to the third out in front. Nothing, no x's left over. I have y to the third, which means 3 y's, which means I'm going to get 1 y. No y's will be left underneath. And then I have a z to the fifth. I guess I'm putting that up here. Z. So I have 3 z's will get circled. That'll give us 1 z outside. And these 2 z's right here can't come out of the radical, right? So that'll be a z squared. So let's see if we can see what we've got here. We've got this 7 right here. I'm going to kind of highlight it in blue. That's coming out because we've got 3 7s circled. So we have a 7. This x to the third is coming out because we have 3 groups of 3 x's. This y is coming out because we have 1 group of 3 y's. This z is coming out because we have 1 group of 3 z's. And then anything left over, remember to put your index in. So I have an index of 3, and then I have this 4 left over. And I have these 2 z's left over, so I have a 4z squared. All right, hopefully that's enough to get you to do your varsity homework on this. This is just simplifying radicals with higher indices and variables. All right, toodaloo.